Hi students, welcome, and here we are going to see limit of sum and difference. Here we are going to discuss the important property which limit follows. It says that limit extending towards a fx plus another function gx can be obtained even if we write fx and gx separately and apply the limits and then add them. There is no problem in that. Similarly, we can take difference of these two functions, and here we can also take the difference. For example, if we talk about limit extending towards 2, a function fx plus another function gx, where fx is defined as x square minus 4 upon x minus 2 and gx is defined as signum of x, let us suppose. Then in that case, if we follow this procedure and find the value of limit extending towards 2fx plus gx, this will give you a value limit extending towards 2 x square minus 4 on x minus 2 plus signum of x. Now if we want to find the value of these two additions, we can't find as such. So what we have to do, we have to put the limit. So we can, by the theorem, do one thing. We can write it as limit extending towards 2x square minus 4 upon x minus 2 plus limit extending towards 2 signum of x. Right? Now we can find that this value will become limit extending towards 2 x minus 2 into x plus 2, and we write it like this, that this is upon x minus 2. This is x square minus 4 by x minus 2 plus limit extending towards 2 signum of x. So what would happen? This get cancels. Putting x equal to 2, we get 4 plus when we take x2 here, signum of a value which is greater than 0, that is 2, will give you 1. So the output is 5. So we can use the theorem that instead of applying the limit to the whole, we can limit to the individual. Similarly with subtraction. Thank you, students.